Thank you, June. Hey guys, good evening, all of you.
Good evening, Law.
Hey, good evening, Ray. So, guys, yesterday we were discussing about the spanning tree protocol, and we have seen how, what is the use of a spanning tree protocol. So, it is used to prevent lay to loop, right? And by default, this protocol is enabled on every switch port interface. Switch port means what? Either it's an access port or either we have a trunk port, right? On both interfaces, this spanning tree is present, right? And what is the main goal of spanning tree ports? To put the port into blocking state. And this is the one of the best, the state, and this is the major role play to prevent the loop over there, right? Let's see how this thing will work over there and how which port they will select to block over there. So I'll do one thing. Okay, so this is my topology we have. So search one. Okay, I'll reduce the size. Search one. This is the search two. Now we have. Okay, this is the search three. Okay, and we have a link connectivity between this guy to this guy. We have a link connectivity between this guy to this guy, and we have some host. We can take example. This is the host over there, right? And this is the host over there. So guys, do we have a loop in my network right now? Can you see that? Is there any loop? Is there any loop in this my diagram or topology? We can say that there's no loop right now. There's no loop, right? Because we have a single path from location source A to the destination B, right? We have a single path, so there is no loop. But what happened if I'm going to put the another cable between this guy to this guy? Now we have a loop. So what do you think over there? Do I have a spanning tree over there right now in this topology? I don't have a loop right now. Okay. See, I don't have a loop in this network. So do we have a spanning tree? Do we have this guy over there? Yeah, we have, right? Because by default it's enabled. By default it's enabled. If you connect the switch, if you connect the interfaces, right? If you just connect the interfaces, you will have a spanning tree. And this spanning tree has came in the picture in the 1984, right? If you remember that. So this is not a new protocol. This is the older protocol. If you have a look, okay. So if you take a one example, I have a one switch over there, switch one, and if you see over there, I don't have any ports over there, right? I don't have any switch port interface, right? That's just a normal switches. I don't have any interface connected over there. And if you put the command over there, show a span tree, what this guy is telling you? Hey, I don't have a span tree over there. Because if you read this line, what I told you that by default, a spanning tree is enabled, right? By default, the spanning tree is enabled on which interfaces? On every switch port interface. On every switch port interface, the spanning tree will be present. Do we have any switch port over there? No. So do we have a spanning tree over there? No. But if I'm going to connect the one more switches over there, and if you see, also this guy does not have any spanning tree. Enable, so spanning tree, no spanning tree, because I don't have any switch port. But once I'm going to connect this guy, automatically what happened? The spanning tree will present. See, now all the information is coming. Did I configure this thing? No, I haven't configured anything, right? Automatically all this information is coming. Don't worry, you will get all the knowledge about this part, right? At the end of the day, you will have everything like what is the hello time, what's priority, and everything, you will get that. But once I connect the interfaces, can you see that previously there is no spanning tree? Just try to understand the concept. Previously no spanning tree was there. Once I add the interfaces, now we have a spanning tree. Guys, 1 minute, I need to make a one call. This guy's little crazy, man. Look over there. Previously, it was no spanning tree instance over there. After adding the one interfaces, what happened? Oh, automatically, right? Automatically, my spanning tree will be enabled over there. Automatically. So what I'm trying to say that right now I have a link connected over there. There's no loop, right? There is no loop in this topology, but still your spanning tree will be there. So now we have a loop. Now we have a loop over there. I'll do one thing. I'll just put the interface name. Okay. So let's tag the interface name. So the interface name is 0/0. This will be 0/1. This will be, it will be 0/0 again. This will be 0/1. This will be 0/0. This will be 0/1. So right now the loop is there again. Because once this person take example, this is a MAC address A and distance of MAC address FFF, right? When this guy will send the packet, it will receive on the switch 2. Switch 2 will send this packet to this guy. It will send a packet to this guy and this guy as well as, right? And from here as well as. See, the loop is there. Yesterday we have discussed this part, right? So I'm not going to recap again. So there is a loop in the right now in the topology. What I can do over there, I need to run the span tree. Once I'm going to enable the span, take example. Once I'm going to enable the spanning tree on the switch 1, by default it's enabled. Okay. Hypothetically, I'm talking about once I'm going to enable the spanning tree on this guy, right? What happened? Immediately, all this guy is going to create our one logical domain. I'll do one thing. I'm just going to remove this person right now because this guy is not used. Okay. Immediately, what happened? This guy is going to create the one logical domain, right? This logical domain. Okay. Again, I'm repeating. This is just a logical domain. Or like you can see that it is going to create the one area, right? You can call it as a logical domain. I'm just explaining you the logical domain term to understand in the better way. Okay, don't call this guy as a logical domain in the interview questions. Okay, because last time one guy, so just logical domain, I'm telling that this to better to understand, right? Logical domain we can call as a area. Now in a one area, what happened? In one area, you need to find a one king, right? Or like a class, in a classroom, what happened? In a classroom, you are going to find the one CR, and we can call as a monitor. You can take example of the corporate world, right? In the corporate world, what happened? Each branch, right? We have a one leader, right? We have a one monitor, and we have a one king. What is the common part of this guy? Manage the people. This is a common thing, right? Don't you think over there happens same thing? In this logical domain, the spanning tree protocol is enabled over there, right? I need to find a one king, right? I need to find a one king, or we can say the one CR, and we can say the one leader to manage the entire switches. I just have a right now switch 2 and switch 3, or switch 1, 3 switches we have, but it could be a 20 switches, right? It could be 100 switches as well as. So I need to find a one guy, right, who will manage the entire domain. How do you elect the king? How do you elect the CRI monitor? And how do you elect the man like a leader of the in a company who has a great knowledge, who has a great knowledge? You can declare, okay, you are the great knowledge, you will be a king, you will be a superstar. Same thing, guys. What happened in this domain? I need to find a one king, one leader, one CR that is going to manage my spanning tree protocol or a spanning tree domain, not protocol, a spanning tree domain. And that guy called as a root bridge. That guy is called as a root bridge. So what happened whenever the spanning tree will be run, right? Every switches is going to exchange the own information. Every switches is going to exchange the own information. This guy is going to tell this person, hey, this is my own information. He's going to share the own information. Same thing, he's going to share the own information to this guy. He's going to share the own information, and he's going to share the own information, and he's going to share the own information. For what? To make a election of root bridge. To make a election of. And what is root bridge? You can call as a root bridge will be a your leader, your king. That is going to manage the complete spanning tree topology. All good. But how does they are going to elect the, like, how they will elect, right? Not how they will elect. This guy will become the root bridge, and this guy, because at the starting of the time he will say that, hey, I would like to become a king. I would like to become a king, and I would like to become a king at the first time. So what happened? Every switches is going to share the own information, and that information is called as a bridge ID. That information is called as a bridge ID. Bridge ID is the combination of two things. Bridge ID is a combination of two things. One, we have a bridge priority. That is by default 327768, and we have a base MAC address. So default priority is 32768. So size of bridge ID is what? The size of bridge ID will be 8, not 8, 6 to 8, 6, 8 byte. 8 byte means what? 2 byte is going to represent at this guy from 1 to 65535. And here the 6 byte is going to represent the base MAC address. I'm talking about the base MAC address, not the interface MAC address, guys. If you have a look, you have something called as a base MAC address that is going to represent the entire switch. Because at the same time, what happened? You have a switch. This is the base MAC address of the switch. At the same time, you have a 0/0 and 0/2 and 0/3. You have a separate MAC for this guy, separate MAC for this guy, and separate MAC for this guy. I'm talking about the base MAC address. That identify the switch. And each switches has a different base MAC address. So here the bridge ID, right, is a combination of two things. One, we have a bridge ID, sorry, bridge priority. One, we have a base MAC address. Guys, why I'm using the term of bridge over there? Because in the 90s, 84, when the Hispanic tree comes in the picture, right? On the time, we call as a bridge, not the switch. That's why many terms in the Hispanic tree protocol, you will listen as a bridge, not the switch. So when I talk about the bridge, it means that I'm talking about the switch. And this is what? This is just a knowledge, right? Bridge ID is information about switch. Like a person has a knowledge, right? And based on the knowledge, we are going to declare, hey, you have a great knowledge, you will become a leader. You have a great knowledge, you would like you can go for the monitor, right? And you have a great knowledge, you will become the king. But at the starting point, if you remember in your classroom, what happened? Every person is saying that, hey, I want to become the monitor, I want to become the CR, I want to become the CR, I want to become the CR. Same thing, he's saying that, hey, I want to become the CR, I want to become the CR, I want to become the CR. Every person. I'm just assuming that the bridge ID of this guy is A plus 32768. This guy should be a B plus 32768. And this guy will be C plus 32768. Now understand one thing. Switch 1, switch 3 has saved the own bridge ID information to this guy, switch 1. So switch 1 has a now C plus 32768 as well as it has a own information A plus 32768. And this guy also saved the information, right? At the first time, every person has the same information. This guy has the information of this guy, switch 1 has the own information, right? A plus, B plus. This guy as well as. This information will be flooded, right? This bridge ID information will be flooded throughout the network. This bridge ID information will be flooded throughout the network. And those person has a lower bridge ID will become root bridge. Now tell me guys, who has a lower bridge ID? See that. Yes, tell me, who has a lower bridge ID? Switch 1, right? Switch 1 has a lower bridge ID information. So what this guy will do, he's saying that, hey, you are the king. Because you guys have a, he will compare, switch 2 will compare itself, right? Switch 3 will compare itself. And what they will found over there, hey, I'm the root bridge, right? And he's also going to tell this person, hey, you are the root bridge. So now you are the king. You are the king. And then king call as a root bridge. And whatever the switches we have, that will become a non-root bridge. So once the switch 1 will declare I'm the root bridge, switch 2 I'm the non-root bridge. And how do I identify based on the information? And BDI is what is the information about the switches, and that information is called what? The information is called as a bridge ID, and the size of bridge ID is what 8 byte. But again, the question is comes in the picture, right? How they will exchange the bridge ID information. It's not like that on an Ethernet cable. I'm going to send, hey, listen, this is my MAC address A and this is my priority. I'm going to send like this, B plus 32768. Whenever you're ordering something from the Amazon and Flipkart, how do you get the cell phone? They are doing the encapsulation, right? They put the phone into the box. They will encapsulate with the Amazon, what we call Amazon sticker, and they will send to you. Then you what happened? You will decapsulate the box, open the phone, and use it. Same thing. Who will carry this information? I need some packet that will carry this information, and that packet is called as a BPDU. That packet is called as a BPDU. Bridge Protocol Data Unit. It's a way to, you can call as a packets or protocol as well as data means what? I'm going to put some information. What information? And this bridge ID, guys, the bridge protocol data in BPDU has a two types. One we have a configuration BPDU. One we have a TCN BPDU. And one we have a TCN BPDU. TCN stands for topology change notification. Right now, we are talking about the configuration BPDU. Right now, we are talking about the configuration BPDU. The name represents the configuration BPDU is what? I need to configure my loop-free topology. So which BPDU I'm going to exchange? I'm going to exchange the configuration BPDU. So this guy will send the configuration BPDU, and this guy will send the configuration BPDU. Again, question comes in the mind. How does switch know I need to send this configuration BPDU to the switch 2? And how does switch 1 will know that how I need to send this configuration BPDU to the switch 3? Do I know about this guy? Does switch 1 has an idea about this guy? Does switch 2 I have an idea about this guy? Does switch 3 know about this guy? No. So in that case, what happened, guys? Whenever the configuration BPDU will be sent, so this is the like BPDU we have, Ethernet packet. And after that, we have a BPDU information. So in this one, source MAC will be what? The source MAC will be a Ethernet MAC address. I'll say that XYZ, the MAC address of this Ethernet interface. And destination MAC address will be a multicast MAC address. 0180 C2 0000 and 00, something like this here, as I remember. Why I'm saying on the multicast address? The reason to send on the multicast address, because I don't know who is my neighboring switches, right? So I need to send on the multicast. And by default, this MAC address is listened by the every person. By default, this MAC address is listened by the every person. So we don't need to care about who is my neighbor, because every switch is by default listening on this particular MAC address. STP operates as a switch communicate with the another. Data messages are exchanged in from a bridge protocol data unit. A switch send a BPD from out of port using a unique MAC address of the port itself as a source address. The switch is unaware of the other switches around it. So BPD frames are sent with the destination address we known as a STP multicast address 0180C20000. And we have two types of BPD. One we have configuration BPD used to configure the spanning tree protocol, and to TCM BPD used to announce something had changed in my network coverage. Change in the sense some interface goes down or a flapping. The BPD masses contains the configuration BPD contains the lots of information, C protocol data, version, masses, tab, flags, and everything. We'll discuss this thing later on. Don't worry about that. Lots of information is there. If you see one thing, I'll show you. I say the CloudSark. Okay, spanning tree protocol, CloudSark. I just show you one thing so that you will get the idea how the BPD will look like this. So this is the spanning tree protocol, and if you see the Ethernet source MAC address is the Ethernet MAC address, and destination MAC address will be a spanning tree multicast C0180C2000. Destination MAC address. And then after that we have a spanning tree protocol and lots of information there, right? But I'm interested only this part, bridge identifier, bridge ID 32768 by default priority, and this is the base MAC address. Forget this part right now. The VLAN number. This is the guy. Forget this one right now. So we have this one and this one. So we are just talking about this part. And why do we need to send the bridge ID information, guys? To elect the root bridge that is going to manage my complete domain. So once we have done with the root bridge, right now, understand in this way. Once you have done, right, once we have elected, okay, this guy will become a king, right? What is the next step king is doing? Allocate the seat, right? Okay, you will be the some minister, some like a money minister, home minister, something like this, right? Same thing, once the root bridge has elected, right? What Spanish is going to do now, it is going to make a after election of root bridge. Now the root bridge will assign the port roles, and we have a port roles like our DP designated port, right? RP root port and block port. These three ports we have: DP, designated port, root port, and block port. So whatever the interfaces we have on the root bridge, if I talk about the very basic definition of the designated port, so we can call this guy as a best port on the segment. Dharni, that is the RPN blocking port called as a non-designated port. Like we have a root bridge, so this is called as a non-root bridge, like this. So whatever the port will not become the designated port will become a non-designated port. So best port on the segment. What is the now the question? What is the meaning of segment now? Segment is like this one. This is the one segment. This is the another segment, and this is the another segment. So three segment we have. 1, 2, 3. You can call anyone. Either you can 1, 2, 3, and 1, 2, 3. Start from anyone. So we have a three segment, right? So best port on the segment is called as a designated port. Now have some look on the theory part. Now have a look. Or let's go further. To extend the BPD masses works toward the goal of electing the reference point we can call as root bridge. Why do we need to extend the BPD masses? To make a reference point as a foundation of stable spanning tree topology. And also loops can be identified and removed by placing a specific redundant ports in the blocking or a standby state. Okay. Notice that several key fields in the BPD are related to the bridge, like a path cost, we have a timer's value, right? These all work together so that network of the switches can converse on a common spanning tree topology and select the same reference point within the network. Reference point is nothing but it's just talking about the root bridge. By default, the root BPD will be sent on every switch port interface at every 2 seconds, so that current topology information is extended and loops are identified quickly. So the common reference point is called as a root bridge. Okay. And we need to extend the BPD at every 2 seconds so that we can quickly identify the loops. The bridge priority, we have a 2 bytes, 02655535, default is 32768 on every catalyst switch. And the MAC address is a 6 byte, right? Once we have done with the election of what root bridge, now what we have to do over there, whatever the ports we have, right, of the root bridge will become the DP, or we can say the best port on the segment. Now the question is that how do I know which one is the best port? Guys, this is totally depend on the cost of the link. This is totally depend on the cost of link. Every link, every link has some cost. Cost you can assume like a metric of OSPF, metric of EHERP, right? Lower cost always prefer. So if I show you the some cost of the some link, every link has a different cost. So if you see, these are the cost. Link bandwidth, old HTTP cost, you don't need to look up this part. You have to look at this guy. Depend on the bandwidth, the cost change. Depend on the bandwidth, the cost will be changed. Right? If you verify one thing over there, the link bandwidth, the lower bandwidth has a higher cost, and higher bandwidth has a lower cost. Sorry. Right? So I'm assuming I have a 1 gig link that has a cost is a 4. So I'm going to assign the cost will be 4 over there. The cost 4 and the cost 4. One more thing. The cost we have a 2 times. The cost we have a 2 times. One we have a root path cost. One we have a path cost. The cost from the non-root bridge, the cost from non-root bridge to the root bridge is called root path cost. The interface cost is called path cost. Remember one thing, at every receiving point, cost will be. So if you have a look, this is my central point. Now understand one thing over there. This is the king, right? Or we can say this is the Prime Minister Modi, right? And whatever the chief ministers we have, this is the chief minister, right? This is the chief minister we have. CM, right? Every CM, right, chief minister is trying to make a good relationship with the prime minister, right? This is how the things will happen in a classroom as well as the CR. Every student is trying to make a good relationship with the CR. In a leadership as well as every people are trying to make a good relationship with the leadership. In a king as well as every servant is trying to make a good relationship with the king. Same thing normally is what happened. Every CM is trying to make a good relationship with the Prime Minister Modi. In this network as well as every non-root bridge is trying to make a good relationship with the root bridge. So take example of this perspective, right now you are present over there. You have to think according to this person. If I would like to go from this side, so I'm sending with the path cost will be what? 0. At the receiving point, what happened? The cost will be added. So 0 and the receiving cost will be added plus 4, right? So 4, and I'm going to send go from here. So the 4 and it will receive on the side 4 plus 4, 8. If I go from this side, what is the cost is happening? 4 only, right? Lower cost. Each non-root switch means that each chief minister we can call it. What is a good relationship with the root bridge? You will have only one root port on a non-root switch. The root port always point towards the current root bridge. The STP uses the concept of cost to determine many things. Selecting a root port involves evaluating the root path cost. Right? So lower cost to reach the root bridge will become the RP port. Lower cost to reach the root bridge will become the RP port. From this side, what I told you that if I go right, what the cost is happening? 4 and 4, 8 over there. So this port will become the RP. And you will have only one root port, lower cost to reach root bridge. Only one RP on a non-root bridge. We have done on this guy. Now this side. If I go from this side to this side, what is the cost is happening? 4 plus 4, 8. If I go directly over there, what is the cost is happening? 4. Every non-root bridge is trying to make a good relationship with the root bridge, right? Every non-root bridge is trying to make a good relationship with the root bridge, and to reach the root bridge has a lower cost will become the RP. So this guy can become the RP. Root bridge does not have any RP. They don't have any RP. All the ports of the root bridge will become DP port, designated port. Because what is the criteria of the designated port? Best port on the segment, right? How do I calculate the best port? Lower cost. So tell me one thing. Always this interface, right? The root which has a cost is what? 0. Because he's going to send the BPD, right? He's going to send the BPD, right? So cost is what out the 0. And when I'm receiving this point, the cost is what? 4, right? Because at the receiving point, the cost being added, right? At the receiving point, the cost is being added. So whenever the root bridge will send the BPD, the cost is what? 0. It will receive, the cost will become the 4. So best, who is the best port on the segment? The segment, who is the best port? The best port is 0/0. So 0/0 always within the DP. So this case, guys, are DP now. DP and DP. Always. This is the best port. If you see the definition of this guy. Okay. To remove the possibility of the bridging loop, the spanning tree make a final computation to identify the one designated port on each network segment. Because DP will send BPD. RP will receive. Blocking will receive. So now on every link, you will have a one designated port. Switch chooses a designated port based on the lowest cumulative root path cost on to the root bridge. Switch always has an idea of its own root path cost, which is it announced in its BPD, right? So if you have a look, if you have a look on in this case, this guy will become the RP, this guy will become the RP, this guy will become DP because this is the best port on the segment, right? Now we have to make an election of this port, this segment, right? On a best port on the segment, its segment has at least one DP, and each switch has a at least each non-root switch, each non-root bridge has at least one RP. Try to understand. This switch has a RP. This switch has a RP. We need to make an election of this segment. So of course we don't have any RP right over there, right? Because on a root bridge, on a non-root bridge, you will have only one RP. So on this particular segment, you will have either one port will be DP, either one port will be DP and blocking. Any one of the port will become a DP or blocking. Any one of the port. But which one? Now understand from this way, right? Again, if I go from this side, from this port, this interface, if I go to the root bridge, what are the cost is happening? 8. From this interface, if I go from here to here, what are the cost is happening? 8. If the cost will time, then it will look up the lower sender bridge ID. if you see in the BPDU as well as you have a root identifier, sorry, bridge identifier, lower sender. One we have a root bridge ID who is a root bridge, and one we have a who is sending this BPDU. One we have a who is the root bridge and who is sending this BPDU. So if you understand this part, he will send the one BPDU to this guy, and he will also send the BPDU on this guy. What is the bridge ID on this guy? B plus 32768, and he's saying C plus 32768. The cost is time. Who has a load sender bridge ID? This guy, right? So this guy has a load sender bridge ID. So this interface will become the DP, and this interface will become the blocking. So now here you will have a loop free topology. So after having this part, right? After having this part, your topology will something look like this. Your virtual topology, and we can say logical topology, will something look like this. All done. This is my logical topology. We can say the loop free topology. This is my physical topology, loop topology. So this is, you can now see the difference. Actually, your topology will look like this, but after span tree will run, it will make a like this topology. That's a virtual. You can't see. That's a virtual. You can't see. That's a virtual. You can't see. Understand one thing. Take example. If you have a look like this topology, then switch one, switch two, and this guy will become the root bridge, right? Because this guy has a plus 32768. This guy has a B plus 32768. So this interface 0 slash 0, this interface we have 0 slash 0, this interface we have 0 slash 1, this interface we have a 0 slash, okay, 0 slash 0, 0 slash 1, and this interface 0 slash 1. In this case, what happened? This interface will become the DP. This interface will be DP. Which interface will be in the RP? Because in this case, what happened? The cost will be tied. He will also send the BPDU, and he will also send the BPDU. Cost will be tied. Then it will look up the lower sender bridge ID. Lower sender bridge ID also will be tied, because in both will what happened? A plus 32768 and A plus 32768, right? A plus, A plus. Then in this case, which one I'm going to look up? Once we have done this part, then if your lower sender bridge ID will be time, then you have to look up for this guy, lower sender port ID. Port ID. So in this case, who has a load sender port ID over there? This interface 0 slash 0. So this guy will become the RP, and this guy will go for the blocking. So I'll draw this topology. That would be a good one. So take example. If you have a look like this one, switch one, switch two. So A plus 32768, B plus 32768. So this guy will become non-bridge. This guy non-road bridge. So he will send the video and he will also send the video because right now DP will send the video, right? So these are DP, this is DP, right? So this is the RP become and they are blocking. Reason lower center port ID because he's sending the information. In this case, what happened? He will put the 0/0 port ID and he will send the port ID will be 0/1. So who has a lower center port ID? This guy. So this interface will become the RP and the 0/1. But if you have a hub, then it will go for the lower receiving port ID. In that's not normally we are using. That's why it is not showing that information, right? Okay. But if you have a hub, it will have a lower receiving port ID. But do you know one thing? All this process, right, that we have done, it took me hours for the 1 hour to complete this one, like RP, and election. Normally, a spanning tree will take the 30 seconds. Normally, a spanning tree will take the 30 seconds. And this guy has to follow the state. And the state will be start from the disable, blocking, listening, learning, and forwarding. Disable means what? No spanning tree. Blocking means what? When you right now this interface is down, right? Right now this interface is down. Once I'm going to up this interface, just for a few milliseconds, just for a few milliseconds, I'm talking about a millisecond, right? Not the second. Just for the few milliseconds, this interface will move in the blocking state just to see is there any loop or not. Just for the few milliseconds, or that nothing else. Just for the few milliseconds, I will move in the blocking state. And in the blocking state, what I'm going to do? In the blocking state, I'm just going to receive the BPD. No data, and even no MAC address learning. Then after that, we have a next state. Once we have, after the spending the few milliseconds in the blocking state, it will immediately move in the listening state. In the listening state, what I'm going to do over there? I can exchange the BPD, but still no data and no MAC learning. If you have a look, read this line. Disable state, right? The ports are administratively shut down by the network administrator or by the system because of the fault condition or in the disable state. This state is special and not a part of the spanning tree protocol. Call as a disabled state. Disable is what? A person is a disabled state. It means that they cannot do anything. Blocking is what? After the port has initializing, right? It begins in the blocking state just for a few milliseconds to check is there is no loop, right? In the blocking state, what happened? A port cannot receive and transmit the data and cannot learn the MAC address in the MAC address table. Instead, a port is allowed to receive only the BPD so that they can hear from the neighboring switches. And this is the most important state, because this is the state that is going to remove the loop. A major role play. So blocking means what? A simple language, guys. Just for the few millisecond, I will move in the blocking state, receive BPD, no data learn, no MAC address learn. Listening state, what I'm going to do over there? A port is moved in the blocking to the listening state if the switch thinks that the port can be selected as a root port or DP port. In other words, port is on its way to begin forwarding, but not. In this listening state, the port still cannot send and receive the data frames, that no data. However, the port is not allowed to receive and send the BPD, not the send, sorry, the port is allowed to receive and send the BPD. That I mentioned the exchange the BPD. That means what? Send and receive. But in the blocking, I just put the receive the BPD. I didn't put the exchange the BPD. Exchange is what? Send and receive. But can I learn the MAC address over there? Still, I cannot learn the MAC address. In this state, what I'm going to do over there, I'm going to make a collection of RP and DP. And those port will become the blocking. It will move in the blocking state again from the listening. For example, one port will become the RP, another port will become the DP, and another port will become the blocking. So those port will immediately move in the blocking state. It will never go for the next state. The next state we have a learning. As the name suggests that what? I'm going to exchange the BPD. I'm going to exchange the BPD. No data transmit, but I do have ability to learn the MAC address. But which MAC address? Not the data MAC address. I'm going to learn the Ethernet MAC address. Not the data MAC address. I'm going to learn the Ethernet MAC address. Ethernet MAC address in the sense of what? The interface MAC address I'm talking about, guys. Yeah, this guy. That means exchange the video. The switch is now can learn the new MAC address to add into the address table. But again, the port cannot yet to send any data frame. So which MAC address I'm going to learn? The MAC address that I'm sending in the BPD, that A MAC address and the 0180C2. So this MAC address I'm going to learn, not the data MAC address. Still, because the data I cannot send, right? And then after that, I will move in the forwarding state. Forwarding state means what? The port is now fully functioning switch port within the span tree topology. Now in this state, what happened? I can click the MAC address, receive the data frame, and send and receive the BPD. So the forwarding state we can call like a, you can do everything. So from here to here, right, from disable to the forwarding, listening will take the 15 second and learning will take the 15 second. That is nothing called as a forward delay timer. 15 second I'm going to spend in the listening state and 15 second I'm going to spend in the learning state. That is nothing called as a forward delay timer. This is a summary that I written over there. Same thing is written over there, nothing else. The forward delay timer is of 15 seconds over there. The forward delay timer is of 15 seconds. Listening 15 seconds, learning 15 seconds. Listening, I can only send and receive the video. The port cannot. Same thing that I, I spoke that. Okay, it's not working. The same thing that I have written over there. So every single port, every single switch port interface will go through the each and every states. Every single. It doesn't matter you have an access port or trunk port. Every single port has go through the all this system. If you don't do any kind of modification, this is the default behavior. If you don't do any kind of modification, if you want to do some modification, then it will do something, right? But default is this one. So to up the interface, to put the interface into the forwarding state, right? The spanning tree take will 30 seconds. It means that for 30 seconds, you don't have a communications between the one user to another user. Can you see the 30-second delay? It's a huge delay, man. It's a huge delay. In a 30-second, you have a 30,000 millisecond. In a 30-second, you have a 30,000 millisecond. And for the normal voice and video traffic, right? For normal voice and video traffic, the recommendation delay is 150 milliseconds. So can you imagine now how many packets you are going to drop? How many packets the switches are being dropped? It's a huge, right? That's why normally what happened, we are not running this kind of a span tree in the production area. But again, to understand the RSTP protocol and MSTP, you need to go through this one, right? Because the behavior, election and everything is same. Nothing is different. You do have ability to modify the everything, but again, right, that's a path manipulation part. So if you see switch one, switch two, and I'm going to add the one more switch over there. Let's make a loop. Can you see the spanning tree protocol is going on? So if you just put the command over there for spanning tree, can you see that listening state, listening? That's why this interface is not green right now. Listening, learning, learning, learning. These are the port rules, designated port, and the state is what learning. And this is the interface cost. Now forwarding state. So right now, can you see that this two interfaces are forwarding DP. It means that this is the guy will become the root bridge. Can you see one thing? Hey, I'm the root bridge because my MAC address is lower than you, right? My MAC address is lower than. If you see the MAC, what is the MAC address of this interface? 001, and I said the 64BA, and then we have a 87BA, right? And if you see the another one, open this guy. Hey, what's your MAC address? Tell me. Show spanning tree. You can see the MAC address of this guy is the bridge ID is going to represent at the information of the switch, right? So MAC address of this guy is a 050 0F67, then 97B7. And if you see the this guy, you need to look the bridge ID information, right? The bridge ID of this guy will be, because bridge ID is talking about the switch information, 01 C9 to A7EE8. So if you see who has a load MAC address, this guy has a load MAC address, right? Again, have a look. The first is bigger, right, than this one. So we have to skip this guy. Then this is the same C9, C64. C is bigger than 6, right? C is right what? A10, B11, C is 12. 6 smaller. So this guy will become the root bridge. So if you see, this is the root bridge. And what this guy is telling you, hey, my priority is what? 32769. How this comes? Default is what, guys? Default is 32768. And after that, what happened? He's going to add the system ID extension, the nothing called as a VLAN ID. Nothing called as a VLAN ID. Why this guy's a VLAN ID is going to add over there? To identify the BPDU masses. To identify the BPDU masses. If I say the one packet over there and another packet, how does switch will identify which this packet is belongs to which VLAN? Because one VLAN means what? One broadcast domain, one logical topology. So how does switch to will know that this packet is coming from which VLAN? So system ID extension is just going to replace the VLAN number over there. So identify the BPDU, right? So maybe you have a question, now we can also use the MAC address to identify the packets. So guys, we don't have that amount of MAC address. That's why we are going to use the system ID extension. This is also called as a MAC address reduction, because we are not going to use the MAC address process, right, to identify the BPDU. We are going to use the VLAN ID. So the normally your priority, normally now understand this part. Normally your Blizz ID is a combination of three things now. What are the things? We have a priority plus VLAN ID, that is nothing called as a system ID extension, and the base MAC address. Three things. The priority will be have a 32768. Then what are the VLANs you're going to write? Default is 1. If you have a VLAN number 10, so your priority will be added as a 10 over there, and the MAC address 8, whatever the MAC address you have. So now the actual priority will be what? 32778. The plus, it will add the plus over there. So normally is 1. So 32768 plus 1, it will become the 32769. And this is the address of root bridge. And this bridge is called as a root bridge. So this information, right? This information is talk about, right? The spanning tree protocol is enabled and root ID. This is the guy is going to do this portion from here to here. This guy is going to represent the root bridge ID information. So the priority is the root bridge, the address of the root bridge. This bridge is a root, and this is the hello time of the BPDU, 2 seconds. Why they will send the 2 seconds? So that they can quickly identify the loop in my network. We'll discuss. You understand the forward delay as well as 15 seconds, right? From listening to learning state, the 15 seconds. We'll discuss the max is time 20 seconds later on. We have a separate topic on this guy. And this guy is going to represent that bridge information. Bridge ID, own information. So again, if you see, both have the same MAC address, right? Reason is that because this is the switch, that is a root bridge. So they have the same one, right? That's why they have the same one. But if you have a look on a different switch, right? If I talk about switch, come on. If I talk about switch 0, and if you see, this guy have a, both have a different information. So it's fine free. Can you see? This is the guy, is the root bridge that has a this MAC address 7BA. That's a root bridge information. This is the guy has a root bridge information, right? And this is my own information. You can see the MAC address is different. So bridge ID means what? This is my own information, my local bridge information, my local bridge information. Information about root bridge. Wow. So the for a few milliseconds, your interface will move in the, you know, in blocking state for just few milliseconds. And then after that, it will go for the listening, then learning, and then forwarding. If you see, I'll show you this part in Nginx 3 as well. So I'll just remove this microphone now. So this is a blocking state. I'll show you the states as well as. So you can see on our switch one, that is this guy. So if you see this guy interface, right, 0/1 is the blocking state. Alternate port, we can call it alternate port means what? Alternate way to reach the root bridge. The state is blocking. And this interface 0/2 is the root port, right? That always pays to the root bridge. The definition was the root bridge what? Root port. Root port always facing to the root bridge. I'll do one thing. I'll show you the states over there. So much time. Span tree. This is actual my switch, not the PC. I change the symbol. Come on, man. Why are you switch? So now if you have a look, right, and of this guy, switch one.
Hello.
Yep, bro.
Sir, after initialization, all the ports will be in blocking state for few milliseconds.
That I'll show you right now.
Okay. During that time only election will happen.
No, no, in the listening state. Election is happening. I'll show you. No? See. Listening state, the root port and name port will be elected. And listening state.
Okay.
So I'll do one thing is Pantry mode. I'm just going to write the one command. Forget this command right now. If you don't know about this part, and I'm going to debug a spine tree. We can call it switch street and debug a spine tree. Call it switch street. And I'll go in the interface. Give zeros last zeros are down on the switch one as well as interface. Give zeros last zeros are down. All done. Wait for some time. No issue. If you see no such and no such, you will see for a few milliseconds, right? I'll move in the blocking state. My gig zeros last zero this interface, right? This sorry, just switch one with this interface as moving the blocking state for the request for the mobile number one. It's normally it's not taking the time, guys. It's seeing the learning stage now after the you can see the 47 to the 2 seconds. It took the lots of time. It's not taking. It's a my GNS issue. It will not take. Okay, so for a few minutes, again, I just want to show you the state. So we are blocking. Then it will go for the learning. Then it will go for the. Why it's not go for the listening and learning? I change the mode, right? Did I change the mode? Yes, I changed the mode. Why this thing is happening? Change the mode, right? 1 minute. Let me check what protocol is enabled to span tree. एक मिनट को यार इस पे दिखाता हूँ मैं ये थोड़ा सा ना GNS3 will not show you the sometimes the proper output of the spanning tree protocol. So better to use the WebIU or the EVNG. That would be good. Or real device is awesome, right? For the spanning tree, real device is awesome. I cannot show you in the Cisco packet tracer because the Cisco packet is a debug command, not somewhat supported once time, right? So better to go. I'll show you the Wireshark in the next class. Okay, I'll show you the states right now. So where's my VMware? I started right. Why am I something look like different? So this guy, let's check this guy. And here we have 131, I think so. Not, yes, we have 131. Open the one span free. Come on. Manual test. Device started. Okay. So right now, no root bridge has elected, right? That's why I say none. So interface is 0/0. Let me debug enable interface 0/0 shutdown and make this interface as well as. Setman one users find interface wing is 0/1 2 3 and interface P1/1 0 2 3. One copy. Interface P0/0. No set. Can you see that? This one. So just for the this is the R. Okay, this is the minute. This is the second. This is the millisecond. R minute second millisecond. So just for the few millisecond, it's 0/0 is a movie in the blocking state. Few millisecond. 114 पे 114 आ गया. Listening to value. Then feeling. Then learning. 15-second estimate in the learning state, right? Calculate from the 18 to 3, right? 15-second learning. And then learning to the forwarding 15-second 18. So total it will take the 30-second. Disable it will not show you because disable is what interface is down and not operational. So blocking, listening, learning, and forwarding. Guys, anyone has any questions, you can ask me now. Just for the today class, because we are not done. We have a 5 days more for this line tree, 4 to 5 days. If you have a question, and we'll see the different topology as well as we have just show you the basic one. I'll show you the different topology as well as. If you have any query about this one today class, you can ask me. Yep. Anyone has a questions about today class? Yeah, Dharni, port priority. Port priority and the cost, and this will we'll discuss the port priority and cost as well as later on. We haven't discussed with the cost as well as. I just show you the basic info, right? How the port election is happening. So in the next class, we'll go through the Wireshark of the BPDU information, right? Whatever the information are present, we'll see the path manipulation in the spanning tree protocol, right? Then I'll show you the load balancing mechanism, and we'll go through the some more topology, right? Difficult topology, how to find right the RP and TP as well. So guys, I'm done for the today, and see you on the Monday. Yep. So tomorrow's Friday. See you on the Monday, and you guys have a great weekend. Bye bye.
The basic class is done on Saturday, sir.
It's done, bro.
Done now.
It's done in the last week. Not last week is done.
Yes.
Bye bye, guys.
Okay. Thank you, sir.
Thank you.
Thank you, La. Good night.
Good night, guys.